This is the video going over the Chapter 5 free response questions on the review packet. Okay, so number one, the numbers that you need to pull out of the chart for the first few parts anyway are circled and boxed there. Okay, I am going to scroll down to page 2 where they show the solution and talk through it, and then we'll scroll down after each problem down to page 3 where they talk about what needs to actually be shown to get full points. Okay, so for part A, it's a conditional probability. What's the probability that you're party Y given that you're male? And so that's just pulling the numbers straight out of the two-way table, and you should get 0.24. Okay, so let's scroll down to page 3 where they talk about what it takes to get full credit for that. Because if you just write down, anyway, let's just look. Okay, so if it has the correct probability and shows work. So if you just give the answer, you don't get full points. You have to show your work. So like as in the what divided by what kind of thing. So, and you'd get partially correct if you accidentally reverse the conditional probability, if it was reverse the male and the party Y, or if you do not show work. So you need to make sure you show work and do the conditional probability the right way. Okay, part B is about independence. So you already did this number. You found Y given male. So now if you just find plain Y, if you were to find that that would be the same number as Y given male, that would show that they are independent. So you find that, pull that straight out of the table, and you get 0.336. So that's a different number than 0.24. Again, if they were independent, the given is a male shouldn't affect party Y, the probability of party Y. So you'd get the same answer. Since these answers are different, that means knowing they're a male changed the probability, and therefore they are not independent or they are dependent. Okay, so let's scroll back down to page 3 and see how it's scored, what's important to have in here. So they want you to identify two values whose inequality, not being equal to each other, implies a lack of independence. There was freedom as to which two values. The one we did up above already used what was done in part A, so it was kind of already halfway done for you, but you could pick two other things. That would be fine. And needs to include the following three components. So correct computations, showing your work and seeing that that's all correct. An explicit statement of whether they're equal or not equal. So that could be a not equal sign, that could be with words. And then on top of that, an appropriate conclusion about independence. So you have to say yes or no independence. So not independent because these two numbers that I correctly calculated are not equal. That would give you the full points. Okay, then for part C, scroll back up to page 2. So they said that we're going to assume now that gender is independent. So the male and female are going to look the same regardless of what's going on with party. And they said that it was the same. Oh, what's the wording? Scroll back up to page 1 to see the original problem. So it says in Lawrencetown or Franklin Township, it's the same as Lawrence Township, but party registration is independent of gender. Okay. So if you find the overall probabilities, so 0.176, 0.488, and 0.336, so not worrying about gender, just worrying about overall party proportions. If we stick to those party proportions for both males and females, that would make them independent. That would mean knowing whether someone was a male or female would not give you any help being able to predict whether they're party W, X, or Y, because the proportions are the same for males and females. So knowing male and female is mathematically not helpful. It's independent from what party they are. So that's what your segmented bar graph would look like. Okay, so then on to problem 2. So this is on page 8 where they actually give you the problem on the solution guide. Again, for some reason, they show the solution twice when I try to print this out, and I don't know how to undo that. And then they also had some mistakes in it. it's the first time I've ever found that, but they had a decimal point off by one place in the solution. And then they waffled between using 0.049 and 0.05, like a rounded version or not. They made different choices throughout. Anyway, so ignore their key. Their key is wonky and messed up. So scroll down to the very end of the packet and use that key, the one I wrote out instead. So first thing to note, even though in this free response question they didn't say make a tree diagram, because on the real AP test they want to leave it open to doing it different ways. On the test in this class, I am going to ask you to make a tree diagram specifically, and you're going to have to draw it on your own paper, take a picture, and turn it in. So here's the tree diagram first. Do that whole thing first before you answer any of the questions. So check all your numbers here. Be very careful about where your decimal places land. Like for instance, this guy is 0.003 because it was 0.3%. You got to move the decimal point 2 spots only. So just be careful on decimal points. Okay, and then at the end, I added up all my probabilities and verified that they added up to 1 to make sure that I did everything correctly. Okay, so then I went back and actually did the math. So first one, they wanted to know what's the probability of being positive. Well, there were 2 ways to do that. You could have the disease and test positive, or you could not have the disease and test positive, as in you got a false positive. Okay, so I just went to my tree and found those 2 guys, what I have circled in yellow there, now in pink, and I added them up. So 0.06894 would be your answer. Now, how you rounded doesn't matter. I did it pretty exactly, but if you rounded a bit and got off a tiny bit, that's fine. Okay, for part B, they said, what's the probability that given you tested positive, that you don't have the disease? So given you got a positive test, what's probably you actually don't have the disease? As in, like, they took all the people who got positive tests and they moved them into a separate room to talk to them. Some of those people actually have the disease, and some of those people don't have it, and they just got a false positive. So of those people who got a positive test, how many of them are false positives because they don't actually have the disease? So I used my conditional formula. No and positive divided by just positive. Found those off of this is off straight off the tree diagram, and then this one is up above, my answer for A, and I got that for my answer. Okay, so the problem on the test, you'll be required to do a tree diagram in full with everything labeled, and then you'll be asked a few questions like this using the tree diagram to get the answer. All right, that's it.